Today we're going to be multiplying and dividing radicals, and you may have done this before, so it might be kind of review for you. But your essential question is, when I multiply or divide radicals, how do I know the answer is completely simplified? So we have a few properties. If you have the root of a number, and there's two numbers multiplied in there. Basically, this is saying that you can separate out the number into two numbers that multiply together. So if I have 50, I can separate it into 25 and 2, or however I would like. And the same goes for division. When I'm dividing a fraction, I can basically split that up and give each of the numbers, the numerator and the denominator, their own separate root. So if the root is over the entire thing, I can separate it to where the numerator and the denominators each get their own root. Now notice on these problems that n is the root on all of them. That means that the root has to be the same. So I can't do a cube root times a fifth root. I can't take a square root divided by a cube root. You have to have the same root or these properties do not work. So we're just going to jump right in and do some examples. It shouldn't take too long. So the first example that we have is multiplication. And so we're going to have the cube root of 12 times the cube root of 18. So what I can do is I can multiply these two together. These properties work in reverse as well. So I can multiply these two together and take each number times itself, or times the other number. So I can multiply the 12 and the 18 and make it under one cube root. So I would get the cube root of 216. Okay, now I can see if I can take the cube root of 216, and I can. It is 6, because 6 to the third power is 216. Now, if it came out to be something else, then we would have to see if we could break it down into any perfect cubes and work it out. So you'll know that your answer is completely simplified when you cannot break down the number underneath the root anymore. Okay, and this one, the root completely went away, so we know we're finished. So if we have the fourth root of 80 divided by the fourth root of 5, well, I can use my property. Right now they're split up. I could put them into one fraction and do it that way. So I could make this equal to the fourth root of 80 divided by 5, and 80 divided by 5 is 16. So then I have the fourth root of 16, which is 2, because 2 to the fourth power is 16. Now again, if I got another number underneath here, then I could split it up into perfect fourth roots and things like that. So let's try this one. We have the cube root of 64y to the 6th. So we need to break this apart. So I have the cube root of 64 and then the cube root of y to the 6th. Now when you have a variable underneath, this number underneath has to be divisible by the root. If it's not, then we have to break it apart. So fortunately for us, 6 is divisible by 3, so it's just 2. So I would have the cube root of 64 and the cube root of y to the 6th. And you really don't even have to break those apart. You can just do each part separate. So the cube root of 64 is 4. And the cube root of y to the 6th, when you do this, you divide the exponent by the root. Okay? So 6 divided by 3 would be 2, so this would come out to be y squared. So if I took 4y squared times 4y squared times 4y squared, if I did it to the third power, it would come out to be 64y to the 6th. Okay. Then the last example I have is m to the 4th over n to the 8th, and it's the fourth root. Well, remember, I can split those apart and give them each their own root. And I can do the fourth root of n to the 8th. And this should be a fourth root. It's kind of hard to see there. I'm going to start over. So it should be the fourth root of m to the 4th over the fourth root of n to the 8th. So again, we take the exponent divided by the root. So because this is divisible by 4, it would just be m, because it would be m to the 1st. And then 8 divided by 4 would be 2, so it would be n squared. So this would be the answer. Okay, so if we're writing radicals in simplest form, this is what we need to do. We cannot leave something under the radical that can be simplified. So whatever your root is, you're going to want to make a list of numbers that are perfect cubes or perfect squares or whatever your root is. So since this is a cube root, we're going to make a list of what our perfect cubes are. So 1 to the 3rd power would be 1. 2 to the 3rd power would be 8. 3 to the 3rd power would be 27. 4 to the 3rd power would be 64. 5 to the 3rd power would be 125. 6 to the 3rd power would be 216. That's good enough because our number is only 135, so we don't really have to divide it by anything larger than that. So we just need to see if one of these numbers can go into 135 evenly. So if we take 135 divided by 27, it equals 5. So we're going to split this up into the cube root of 27 times 5. So just like before when we were multiplying numbers together to equal the number underneath, you can do it reverse. So we want to come up with perfect cubes so that we can take a number out, and we're going to split it up. So we have to split this up into a number that is a perfect cube. So we divided it by 27, we got 5. So what is the cube root of 27? Well, the cube root of 27 is 3, so that's going to come out. So then we will have 3 times the cube root of 5 left over, and that will be our answer. And I know that I have the answer because the number underneath the radical can no longer be broken down. So I can't divide 5 by any of these numbers other than 1. You'll always be able to divide by 1, but I can't divide it by any other number, so that's it. Let's try a different example. So here's one with division. So I can't take 7 divided by 8, so really it wouldn't help me to put this together and simplify it. Now you guys might remember last year when we did rationalizing the denominator with fractions. I think we did it earlier this year also. So if you have like the square root of 2 over the square root of 3, we can't have a square root on the bottom. It's the same process. You can't have a root on the bottom of the fraction, so you have to get rid of it. So what we did was we multiplied it by another square root, and then we got the square root of 6 over 3, because these canceled out. Now the reason why this canceled out is because there was 2 of them, and it's a square root. So if you have 2 of them and it's a square root, it will cancel each other out. And I can take the square root of 9, which is 3. Now for this one, I have a 5th root, so it's a little bit different. So I would either have to multiply it by the 5th root of 8 4 more times, that way I have 5 of them, but that would be pretty complicated. So something else we can do is we can make a list of our perfect roots, 5th root. So 1 to the 5th power would be 1. 2 to the 5th power would be 32. 3 to the 5th power would be 243. And I can keep going, but basically what I'm trying to do is I'm going to try to turn this into a perfect 5th root. So what can I multiply 8 by to get one of these numbers? Well, I know that I can turn 8 into 32 by multiplying by 4. So I'm going to multiply this by the fifth root of 4, because 8 times 4 is 32, and then I can take the fifth root of it. Now, whatever I do to the bottom, I have to do to the top as well. So 7 times 4 would be 28, so I get the fifth root of 28 over the fifth root of 32. Well, 32 is a perfect fifth root, that's why I did this. So this would cancel out and be the fifth root of 32 is 2. And then I would just have the fifth root of 28 on top. Now, as long as this is completely simplified, then that would be my answer. So since I cannot divide 28 by any of these numbers over here, then my answer is completely simplified. So this would be the answer. All right. So you guys need to go back and answer the essential question and write your summaries, and then you can start on the assignment. Thank you.